Good morning, my dear students of Standard 9. Welcome back to the chemistry class. Dear students, today we will start a new chapter, that is periodic table. Now, what is periodic table? The periodic table is a tabular display of the chemical elements which are arranged by atomic number or electronic configuration, so that elements with similar chemical properties appear in vertical columns. Dear students, this is the periodic table. There are total 18 groups and 7 periods. There are total 18 vertical columns and 7 horizontal lines. This is periodic table where the elements are arranged according to their increasing atomic number. Atomic number 1 is there, then 2, then 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. In this way, the elements are arranged. And there are similarities on their properties of the elements of same column, that means same vertical lines. Now, today in this class, we will learn about this periodic table. At first, we have to know about periodic table, about the history of periodic table. Now, background of periodic table. In 1789, French chemist Antoine Lavoisier first divided the elements into two groups, metals and non-metals. At first, at 1789, scientist Antoine Lavoisier divided the elements into only two groups. In one group there are metals and in another group there are non-metals. Now, after that, in 1829, the scientist Daubrier found that groups of three elements show the same kind of features. Groups of three elements. He proposed the law of triads. Here, he organized three elements according to their atomic mass. Dear students, look, according to their atomic mass, because at that time atomic number was not invented. And he found that the arithmetic mean of the atomic masses of the first and third element is a triad would be approximately equal to the atomic mass of the second element in that triad. What he found? He found that the mean of the atomic masses of the first and third element in a triad, that means he made a group of three elements and he found that the mean of atomic mass, the average mass of first and third element in that triad is approximately equal to the atomic mass of the second element of that triad. And he gave a law. This law is called law of triads. What is the law? The mean of atomic mass of first and third elements in a triad is approximately equal to the atomic mass of the second element in that triad. Look here, this is Daubrier's triads that he arranged lithium, sodium and potassium, the first, second and third elements, and their atomic mass 6.9, 23 and 39.1. The average of 6.9 and 39.1 is equal of 23. That is, it is the triads law. The mean of atomic mass of first and third elements is approximately equal to the second element's atomic mass. Again, he arranged calcium, strontium and barium, these three elements, and their atomic masses are 40.1, 87.6 and 137.3. Here also, the mean of the mass of these two is approximately equal to the mass of strontium, 87.6. Again, he arranged chlorine, bromine, and iodine. Here also, the mean of the atomic mass of first and third element is approximately equal to the mass of bromine. It is called Dobryniar's triad's law. Now, then after that, at 1864, English scientist John Eyre Newlands gave a theory called law of octaves. He gave another theory, that is, according to the Newlands law of octaves, when elements are arranged in the order of increasing atomic masses, the properties of the every eighth element starting from a given element are a repetition of the properties of first element. What is this? Look, here this is hydrogen, lithium. Look, at that time the inert gases were not discovered. So after hydrogen, not helium, there will be lithium. Lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine. Again, neon was not then. So sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine. So the mass, the property of first and eighth element is equal. First, second, third, fourth, fifth, sixth, seventh, eighth. Again, if beryllium is the first element, then with beryllium the properties of magnesium is same. If boron is the first element, then with boron the properties of aluminium has similarity. In this way, he found that when the elements are arranged according to their increasing atomic masses, then every eighth element have the similar properties. Okay, this is called law of octaves. Here he arranged the elements like this way: hydrogen, lithium, beryllium, boron, carbon, nitrogen, oxygen. Then eighth element again fluorine, sodium, magnesium, aluminium, silicon, phosphorus, sulfur. Again eighth element comes chlorine. So that means here the properties of hydrogen, fluorine, chlorine has the similarity. Lithium, sodium, potassium have the similarity. Beryllium, magnesium, calcium have the similarity. It is called Newlands law of octaves. After that, in 1869, Russian scientist Mendeleev published a table with only 63 elements, because at that time total 118 elements were not discovered. There were only 63 elements, and Mendeleev published a table with these 63 elements. He arranged the elements in 8 vertical columns and 12 horizontal lines. Here he organized the elements with similar properties in the same group. He made the table with 8 vertical columns, that means 8 groups, and 12 horizontal lines, 12 periods. Here he organized the elements with similar properties in the same group, and the elements were arranged following the law that is called Mendeleev's law. What is the Mendeleev's law? Physical and chemical properties of the elements return periodically as atomic mass of the elements increase. Physical and chemical properties of the elements return periodically. That means they will be repeated as atomic mass of the elements increase. That means the elements of same group has the similar properties. The elements of same group have the similar properties. They are repeated. But there are some defects in Mendeleev's periodic table. This periodic table was not 100% correct. In this table, the elements were arranged according to their increasing atomic mass. But in this way, the atomic mass of argon is 40 and the atomic mass of potassium is 39. So the atomic mass of argon is more than the atomic mass of potassium. So argon should placed before potassium. In this way, argon should placed before, not argon should placed after potassium. But the properties of potassium matches with other alkali metals where there are lithium, sodium, etc. and argon should sit with other inert gas. But if argon should be placed after potassium, then potassium will come with other inert gases, helium, neon, and argon will go to other alkali metals. The first group elements, lithium, sodium, they are called alkali metals. We will learn about this in details after this. So, potassium should sit with inert gas and argon should sit with alkali metals. So, if this happened, then the beauty of the periodic table will be hampered. Beauty of the periodic table not. If this happened, then the properties of the same group will not be similar, because the properties of potassium will not match with other inert gases and the properties of argon will not match with other metals of lithium, sodium, alkali metals. So potassium was seated with other alkali metals and argon was seated with other inert gases. But the atomic mass of argon is 40 and potassium is 39. So Mendeleev's law was not followed there. The same happened for tellurium and iodine. Here also the atomic mass of tellurium is 128 and iodine is 127. So if iodine seated before tellurium, then iodine goes to other elements and tellurium will come with other halogen, chlorine, fluorine, bromine with them. But the properties of tellurium is not similar with other halogen. So these were the limitation of Mendeleev's periodic table at that time. But after that, the periodic table is corrected. But when? After invention of atomic number. In 1913, at 1913, Moseley invented atomic number. And after invention of atomic number, in 1913, scientist Moseley proposed to arrange the elements in the periodic table according to their increasing atomic number, not according to the increasing atomic mass. He also corrected the law of Mendeleev, and the corrected law is physical and chemical properties of the elements return periodically as atomic number of the elements increase. Same law, just Mendeleev told that physical and chemical properties of the elements repeat periodically as atomic mass of the elements increase, but Moseley corrected the law and he told that physical and chemical properties of the elements of periodic table repeat periodically if the elements are arranged according to their increasing atomic number. And after invention of atomic number, there is no dissimilarity of the elements in the periodic table, because the atomic number of argon is 18 and the atomic number of potassium is 19. So as usual, argon will be seated before potassium. So argon comes with other inert gases and potassium goes to other alkali metals, and tellurium and iodine also. The atomic number of tellurium is 52 and the atomic number of iodine is 53. So iodine will be seated after tellurium, so iodine will go to other halogen groups, and all the limitation of Mendeleev's table was corrected. However, in chemistry, the modern periodic table with 118 elements is an outstanding focus of knowing all the elements at a glance, because if you see the periodic table, then you can know about all the elements of the periodic table. You have no need to memorize the properties of each and every element. If you know the properties of element of one group, you can tell the properties of the other elements of that group. So periodic table is very important to know the properties of the elements of all the elements. Now, characteristics of periodic table. Look, this is the periodic table. There are total how many periods? There are total 7 periods. Look, There are total 1, 2, 3, 4, 5, 6, 7. These horizontal lines, these are called periods. There are total 7 periods and total 18 groups, 18 vertical columns. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18 vertical columns in the periodic table. All periods start with group 1 at the extreme left and extend up to group 18 at the extreme right. All the periods. This is the first period. There are only 2 elements, but the first element is in group 1 and the second element is in group 18. In this way, all the periods started with group 1 and ends on group 18. A small table of 2 horizontal rows and 14 columns displays the lanthanide and actinide elements beneath the main periodic table. These are the part of period 6 and 7 of the main periodic table. Already you are thinking about these two. There are total 14 elements on these 2 groups. The first groups, these are called, the first group, this is called Lanthanide series, and the second group, this is called Actinide series. Actually, these all 14 elements should be placed with lanthanum of this position, but total 15 elements cannot be placed at the small box. So, only lanthanum is seated here and other 14 elements are placed at the beneath of the periodic table and named as Lanthanide series. There are total 14 elements and their position is group 3 and period 6 here. And these 14 elements, they should be placed at group 7, period 7 and group 3 with actinium. But all these 15 elements cannot be placed here, so they are placed here and they are named as Actinide series. Period 1 contains only 2 elements, hydrogen and helium. Period 2 and 3 contains 8 elements. There are 8 elements on these 2 periods, period 2 and 3. And period 4 and 5 contains 18 elements each. Period 4 and 5, in every box there is an element. So there are total 18 groups and there are total 18 elements on period 4 and period 5. But period 6 and 7, there are how many elements? Here it is seen that there are 18 elements, but here look, with lanthanum, these 14 elements will also be seated. So there are total 32 elements, these 18 and these 14. And period 7 also, there are also 32 elements, these 18 and with actinium these 14 elements will be seated. So total 32 elements. Actually these are the part of periodic table, but if these two are seated here, then the beauty of the periodic table will be hampered. So they are seated at the beneath of the periodic table. Group 1 contains 7 elements, Group 2 contains 6 elements, Group 3 has 32 elements, Group 4 to 12 contains 4 elements each. Look, Group 1, it has total 7 elements. Group 2, there is no element, so there are how many elements? There are 6 elements. But group 3, how many elements are there? There are 4 elements and these 14, 28 elements are here. So there are total 32 elements. From group 4 to 12, there are only 4 elements. But group 13 to 17, there are 6 elements and group 18 also has 7 elements. These are the characteristics of periodic table. Now, look, 15 elements with atomic number 57 to 71 are called the lanthanide elements. Look here, from 57 to 71, 57 lanthanum, and from 58 to 71, these are also the elements of group 3 and period 6. All these elements are called lanthanide elements. In the same way, 15 elements with atomic number 89 to 103, 89 actinium, and from thorium to this 90 to 103, total 14, and also actinium. These 15 elements are called actinide elements. Physical and chemical properties of elements belonging to each of these two categories are so close that they have been put separately in two separated rows. Their physical and chemical properties are so close. These 15 and also these 15. Now consider the periodic table in terms of properties of elements. Properties of elements change from left to right in the same period, and the physical and chemical properties of elements of the same group are almost similar. Okay, here the properties are changed gradually from left to right, and the properties of same group elements are same. We will read these properties in our next class. So dear students, today up to this. So thank you everyone. See you in next class.